So you have a challenge with this spray. Go ahead. Tell me
Yep.
about.
So the existing building was had an exterior front deck that was later enclosed, right? So technically, this was the exterior wall initially, and the loads were being transferred down to the basement, the foundation, right? That was
Mm-hmm.
before it was enclosed. Now,
Mm-hmm.
after it was enclosed, they made openings in the inside of the house, but
Mm-hmm.
then maintained certain beams and columns within this front location. Now, coming into this building, I wanted to make those openings bigger and have a bigger connection in those public spaces, which included removing those beams and the columns to make it more open concept.
Wait a minute. So what you're
Um,
saying is this whole diaphragm or
yes,
element is your initial home. That
yes,
so then they did this addition, and as they did this addition, this thing still has some load bearing elements within it,
yes, yes,
but you wanted to basically remove some of that and create a connection between that front addition and the interior of the house. Is that right?
yes.
All right, I understand it. Hmm.
Okay, so with that, um, if you look, so first of all, I'll have to propose a new foundation wall here to support the loads of this exterior wall to start with, right? Now, moving from that to, in order to
Well,
transfer,
they were already being supported, so you don't necessarily need much to support it because it's already been supported, right?
it's already been supported, yes, but reinforcement for us, reinforcement purposes.
Okay.
Um, and so, that's not the page. Let me just Right. So in a way to transfer the loads, I was trying to calculate the load from the ridge beam into a column that is going to be split by a door header, and then down into this beam that is going to be transferred within this wall and this exterior wall. This is the circulation space from unit to unit. And then this goes now to that existing foundation wall. Um,
Completely confused with what you're trying to do. Hold on, go back out. So um so we have our rich beam that's
right.
supporting because this is cathedral is why you need it mainly.
Yes.
So
Yes.
which is supporting the load of half of the load of this and half of the
The
load of
tributary of that and
great.
tributary on the arm of the left,
So
right?
how it goes from one extreme of the side to the other, and you're sitting it on a post that has some sort of header that goes down and goes down. After it goes down, that's an exterior wall, right? So
Right.
that's an exterior wall. Why are you showing me another beam that then sits on these walls and these walls?
Because all
Why aren't you trying to continue to do the same thing you just did with your headers around? Like why doesn't that try to sit on something and then go down and then this probably another header here and then figure out how to go down and then figure out how to go down and go down, continue to go down. Why are you transferring the loads onto a beam into the exterior side? Like, is there a particular reason for that?
yes, this section is actually pretty deceiving. This is not the exterior wall. Remember, this is the location as to which we are taking the loads from. When it comes down here,
Beautiful,
this is
beautiful,
the
beautiful. No, no,
living
no.
room.
I completely understand what you're talking about. What you're saying is here I have my header, I mean my post, here I have my
Yep.
header, here I have this piece, here this piece. I need a beam because I want to create an open concept. I want to go all the way down. I want to go all the way.
Right. Right.
Beautiful, beautiful, beautiful. I understand that 100%. Looks great. So now you need to size a beam that will have 2 point loads, 2 point
Right.
loads. Depending on how big the opening is, are you opening the whole thing?
I am opening the whole thing, but then the intention was for it to come into this partition wall that separates the units from the circulation space. My biggest issue with this was loading this. Number one, it was a question of the ridge beam on an existing roof that you're adding, number one, a dormer on both sides, right? Adding a dormer on both sides. And then number two, how to phrase that on struct calc, because I
Mm,
think I was having an issue with that.
okay.
The other parts I'm able to do it. I just didn't know, number one, how to add. Do you propose reinforcements on the existing ridge beam for the existing roof? How do you calculate all of that, and then how do you program that into struct calc?
All right. So can you show me a quick I will probably need a floor plan and I probably need a floor plan. Like that attic floor plan might be the best one. All right. So okay. So what we understand that's happening. We have something here, something here, here. This way, that needs to sit something here also, ideally.
Yep.
Okay. All right. Then these guys somehow will have to connect to that. Then there's another dormer on the other side, right?
Yep.
Is
Yep.
this
On
what I
this location
is
where you
this
have,
what I
yep.
understand? All right. So there are a couple of things. This has to be done in phases, and you have to understand kind of like the process. So this is gonna be a multi-loaded, multi-span ridge beam that you're gonna be needing to do. Um, it's like a trapezoidal beam, to be honest, because it's gonna have a trapezoidal load here that's X distance, then it changes to be Y distance and Y distance in here, and then it changes in here. So that's it's like a multi sort of loaded beam. Now I'm not gonna use real dimensions, but I'm gonna show you real quick what I understand needs to happen, and then
Right.
you tell me if you understand that phase. The first
Okay.
phase is we gotta size the right beam. Okay, I'm gonna share my screen real quick.
Yep.
See, right, so call here, and to help me out, can you see my screen real quick?
Yeah, I can see your screen.
To help me out, I kind of did a screenshot of what you were doing, so that okay.
Yep.
All right, so that's it. We're gonna have to go to like the multi-load and multi-spam beam. It just gives me a lot of options that the other ones don't give. First thing I'm gonna ask myself is how long is this guy from this point to this point? Looks like it's 3219.
32. Yep.
Plus
So
or
round
minus,
that
because
up to like
it looks
33.
like yeah, it looks like it's to the edge. So it's to here that I need it, not to here. But okay,
Wait, the
that's
distance of from exterior wall to exterior wall, or the distance of the roof?
from exterior wall to exterior wall would have been the best. But that's fine.
Okay.
That's fine. 30,
Yeah.
just got a 33. This beam's gonna be 33 feet long. Beautiful, no problem. So that doesn't mean anything yet. We gotta tell it now what is gonna be supporting either side. So you're like, okay, what do you mean now? We gotta start understanding this in terms of like point A from point A to B, from B to C, from left side to right side. It gets very confusing, but that's what these guys are for right here. The trapezoidal loads. That's what this is for.
Okay.
So if we're picking A to be this, right? And your dormer, so we're gonna have a load right here, whatever that is, right here,
Mm-hmm.
right? So let's say that goes, I don't know, like 8 feet, maybe six, yeah, like 8 feet. Okay, so that we're gonna think about in terms of left and right. So in this case, left, the load will start at 0. And it's gonna go towards 8 feet. And one thing I typically do, because now it's asking me for pounds per square foot, pounds per linear foot.
Mm-hmm.
I don't have the pounds per linear foot. So what I do sometimes is the eye size of roof raft. And by the way, you got to call it roof here so that we know it's a roof. I just sized some roof rafters. Why are these roof rafters gonna be made out of unless the pitch?
Sorry, ask that again.
Why are the roof rafters gonna be made out of, and what's the pitch?
Pitch is 10.
10 and okay, 10 and 12.
Yep.
And how long are they from the center to the edge? This distance.
Let me get that for you. 11.7.
So 12. You have like a tiny little overhand, right? It's not too much.
Yep.
So I'm gonna call it like 0.6 inches, 0.6 feet. So okay. So that's that. So we already have that. Why are you making it out of?
2 by 12. 2 by 12.
2 by 12s. Okay. What distance are you planning on doing it?
16.
Beautiful. You save him. This thing's gonna wanna save, so I'll save it. Right. All right. So I save it. And you're like, what do you do that for? It's because I want to know the load, and I don't know where to come up with the load. So what I do is I know that on the left side, this thing's gonna be from 0 to 8 feet, and we're gonna use that load that will include the snow load onto that location. Boom. That's that side on the left side.
Okay.
That's pretty much the same thing on the, well, I guess that's the right side. On the left side will also be about the same, but the thing is, it's longer. Isn't that right? It's gonna go from here all the way to here. What's that number approximately? The 13.7? We don't need to know the right things yet. Like you cannot do it yourself. But it's the 13.7, right? I think it likes that, right?
It's about 16. Yeah, no, 13.7. 13.7 from exterior wall is 13.7.
We're gonna call that 14. So we're gonna say that from 0 that goes to 13.8 or so. I mean, just do correct.
Then all the others.
All right, so hold on. Just make sure to do correct decimal feet so you get it right. And then you're gonna come here and you're gonna load these guys because they're gonna about be the same. Okay. So you've already loaded one side and the other side. You're like, wow, that's pretty cool. Yeah, pretty cool. Now we go into the next piece. It's like, okay, so now, because they have to go the whole way. So now on the right side, I guess this is the right side. You have, it starts right here and it ends right here. You have your dormer, right?
Yeah.
One thing, just so you know, technically you should do it with another rafter that's gonna have another slope because your slope changed on that particular location. Does that make sense?
That makes sense. Is it also influenced by the fact that, for example, in Somerville, they expect you to be 1 foot offset from the ridge beam?
So what you're gonna do with that offset, just so you know, this is what you're gonna do with that offset. You're gonna have the ridge beam, whatever member, right? And the roof is doing this, and the roof is doing this, and you're doing this 1 foot off of it. They're just gonna have to figure out how to attach it
to the rest of it.
So that is, yeah, either it's gonna hang off of it, but it's still gonna have to go. Does that make sense? I think you understand.
That makes sense.
You're just gonna hang it. It's not gonna be floating. It's gonna be hanging off of the beam.
Right. Okay, but it's still connected to the initial
to the ridge beam. It has to be. It has to. There's just no way. So that's it. We're gonna come here and then we're gonna say, okay, we're gonna do another roof rafter. Roof rafter. Where is roof rafter? I'm always getting it. No. Yeah, right here. So that other one, what's the slope of that?
Still 10. Oh, wait, which one?
No, that's the left side.
The first dormer?
This right here, where the stairs are.
3.
3 and 12?
3, yep, 3 and 12.
Got it. And the length will be about the same. So what the length was with before? Because it's gonna have to go the same distance.
The distance of
this right here. It's the same, right? It's gonna have to go from the
Yep,
center.
same.
What was that? It's okay.
11-7.
I can get it from this. Wow, it says 12. We said 12.
Okay, 12.
Yeah, I don't know where you got that. It said 12. All right, so 12. I'm just gonna put a 0.6 overhang. And we're gonna be doing it made out of the same thing. 2 by 12, that's 16 center. Okay, process problem, so I save it. And you're gonna go and say, okay, that one on my multi-loaded multi-spam, that one starts where this one ends. So this one ends at 8. So that one needs to start at 8. And it needs to end. Where does it need to end? It needs to end. Let me see my sketch. Basically, it doesn't end at the very end, by the way, but
No.
it ends. What's that distance? You have the model. What's the distance
Yep.
from this dormer to this side?
19.6.
19.6. That's the distance. So starts at A, which will be 0. Hold on one second. Start at A, which will be 0. It ends at 19.6. You know what I'm trying to do, right?
Yep.
A plus 19.5. So he ends at 27.5. Boom. And it's going to be that roof rafter number 3. Let's see how that looks. That looks right. Beautiful. So far, so good. Now, what do we need to do? We still need to go to the left side. By the way, I think you can add more loads. I don't see the button, but I think you can add more loads. This is weird. It's limiting me.
Yeah, I was about to ask, is there a limit towards how many loads you can add on it? But
Yeah,
okay.
I think there's a way of adding more. I just don't. I've seen Jose Playtas do certain interesting things. I don't know how he does it, but yeah, this probably an option. So that's it. We go here back to our sketch. Say okay. So now we're gonna have basically the same kind of joist as this one, but from here to here, which is 3.3 foot 6. You know what I could do? I just don't want because I want to also get this done. So let's forget about this 3.6 for a second. We'll add that in a minute. Okay, we'll add that in a minute.
Okay.
So what we're gonna do then, because we know the process, we're just gonna come here now. What's the length of this here to here? By the way, this one seems longer, just so you know.
15. Which one?
This is longer than this guy's. So this is gonna be different. So what's the length of what's system 6?
15.6. The length from. Wait, give me a second.
Yeah, this one's
Yes,
are
it's longer. It's longer because initially there was an extension from the initial massing. 15.5.
15.5. So that means I have to come here and create another one. It's gonna be 16.5. You're like, whoa, this is a lot of work. It is. You have to follow your loads. Come here. What's the slope gonna be? 3 to 12 too?
Yep.
And this is now 15.5 or so. And we're gonna put a 0.6. And we're gonna make sure this is 2 by 12. 16. Okay, so we go back to this one. And we know that one starts. See the process? That one starts where the second one ended. So that one starts at this T where the T3 ends. So it's this one right here. That one starts at 13.8 and it ends. So what's the distance from here? So well, it will be that plus whatever the length of the member is. So what was this? You tell me that distance right here?
15.6.
No, you tell me this 15.6.
Yep, that's 15. No, that was 15.5. That's 15.5.
And
And
this
then the
is
distance from wall to wall is 15.6. Yep.
okay. So that will be 13.8 plus 15.5, like 29. Okay. Now we're gonna
Yep.
come here and load roof rafter number. Boom.
Okay.
That's weird though. It should end
Because
right at
that
the
goes
line.
to the all the way to the end. Yeah.
Yeah.
Maybe it's didn't we start with an arbitrary ridge beam length at first?
No. We said 33 feet. Actually,
33. Okay.
isn't that the length of the beam?
No, that's the length from end to end
Yeah.
of the roof, not of the exterior walls. For the beam
Oh,
is 30, 34.
the beam is 30?
Yes, 34.
No, but that doesn't help me.
No. 30 feet, 4 inches.
Oh, call it call it 30 for now. Oh, so now you see that now it's making sense because I'm like, why do we have this little but yeah, 30, let's say 30.3. 30, 30. Okay. About that. I mean, there's like some wall thing that's going on. No problem.
Right.
I'm okay with it. I'm okay with it. So now you've virtually loaded this thing minus this little piece right here. You're like, what do I do then? Like, what do I do? Right? Like, I have to do something.
Mm-hmm.
You could add 3 more feet to whatever this thing is. Whatever the first one that we did was.
Preferably, yeah.
So, like, if this one was 8, that ended, plus 3, that's 11.
11.
Wouldn't it make the same sense? By the way, 8. Weird. It's weird. It looks so weird. I'm not gonna question what the
Maybe
diagram looks like. It doesn't matter to me.
it's because also from the starting point of the second one, that also needs to change, remember?
This one right here.
Yeah.
You know what? Forget about it. No, it doesn't. It doesn't matter because we're just adding 3 more feet of load. It's just for the sake of adding 3 more feet of load so that we know that it has 3 feet of tributary width extra.
Yep.
Of area.
Yeah, but like if you're adding it from the first one, then you like your second one is indicating the starting point. It's no longer 8, it's 11. You get what I mean?
But that doesn't matter.
Okay.
Yeah, I'm just saying add 3 more feet of length of the load and call it a day. And now it tells us. And then that now we have virtually loaded this beam. This is correct. By all standards, this is correct.
I have a question up until that point.
Okay.
The way we have loaded the right and left rafters, does that matter if you're loading a shed roof versus a gable roof versus does that change anything?
Well, the only thing that changes is the slope of the dormers that you're adding to this.
Okay, so it says okay, gotcha. All right.
Remember that you change the slope of each one of them?
Yep.
Because the loads are acting differently. By the way, for the purposes of structure, this and this and this and something less drastic than that are all the same. For the purpose of the structure, we treat it like load going perpendicularly down. It doesn't matter that's going in a slope. So it doesn't matter.
I just thought the connection was, but that's okay.
The only reason why it would matter a little bit more is because the snow load may sit on one versus the other a little longer.
Okay.
But for the purposes of calculating structures, it's like going down straight on a distance. Okay.
Okay.
Now you size your LBL. In this case, I think we're gonna have to go with something pretty robust. be honest. Yeah, that's what I would do. 4 18-inch LVLs.
Okay.
Let me see if 3 does it. No, yeah, 4. That's what I would do.
By
All right,
what
so
percent? 25? Okay.
yeah, so that's that. Okay.
Okay. Now we
Uh,
load
now we
the
do your
beam to the
column.
columns.
Yeah,
Okay,
so now you
gotcha.
come to your column. Easy peasy. Come here, put it in, pick one point. Okay, boom. Then
Okay.
make sure it passes. This is gonna probably have to be a LVL. Yeah, it's gonna probably have to be a square LVL, 5.5, 5.25 by 5.25. Good. Then that one's gonna need another header because that's what you're doing. You
Mm-hmm.
know how to do that. That
Yep,
header is only
yep.
gonna have a point load. Don't worry about the rest.
Mm-hmm.
And then you're gonna have to size 2 other posts that will likely have to be 5.25 and 5.25 each side. So you could probably use uh, studs too. By the way, you could use like a 3 2 by 4s together, 3 2 by 6 together. But that's something you have to test. Now that's it. That's it.
Okay.
So we're good on this part, right?
Yeah, yeah, yeah.
So
We're good on
this
that part.
this
That loading is
exercise
what.
this exercise is super like I'm gonna probably do a little screenshot or something. I'm recording this. I'll put it into a YouTube channel. Don't be lazy and watch it when you're doing it, because I know you may like be like, dude, I'm busy. I can't watch this. Because this was fast. But the mindset like of why do you use this multi-loading, multi-span beam? What is going on? What is this? What is that? That stuff is important to understand it.
Right.
Now the rest is pretty straightforward.
Mm-hmm.
Um, there are other things you may want to be aware of, but they're negligible. And is the fact that this wall has load and you're gonna have a beam below. So just size a wall onto that beam. Have you ever sized a wall onto a beam? Yeah. And just make sure it's gonna think of it as a square, but I know it's triangular, so it's gonna have more load than what it really needs to be. Because you're telling me that then below these babies right here that are point load, you're also gonna have a beam that's gonna support it, and it's gonna sit on a well, actually it doesn't go to the outside, you're gonna have it somewhere here because this wall continues below, right?
Mm-hmm.
And then you're gonna sit it on the outside wall, right?
Right. Right.
Mm-hmm. So so make sure to size put a wall so they also so you know what I'm saying.
Yep. Yep. Yep.
You're gonna have beam, you're gonna have column, column, header. Exactly the same sketch you just showed me.
Yeah.
You're also gonna size. Put this size. Technically it's up to. And then you're gonna size your even though it's a wall though, you have to size your columns though for this beam. You know how to put the different points. You have your beam and it's gonna have
Mm-hmm.
one point load
Mm-hmm.
and another point load.
Mm-hmm. Mm-hmm.
Okay, got it. All right, so I think this is good. I'm gonna stop this video here so it doesn't go too long. Then we can answer
All
the
right.
other questions.